All right, so today's lesson is 922, and it's all about cross-sections. So I'm going to move on to a page where I can write and define something because you've got homework over on that board too if you want. Octavio, what's up? I mean, I'm still deciding what we're doing. So chapter 9 is the end of this book, but we are not ending. We're moving on to CC3. So I'm still deciding what we're doing for closure. So you can be certain of those three homeworks, 922, 23, and 24. Beyond that, don't keep working. Like, don't keep doing stuff beyond that. Don't do 9-3 work. We looking for graph paper? All right, we good? So, cross sections. And guys, I want you to write down whatever definition is going to make sense in your head. A cross-section, let's just talk about this before we try to write down any formal definition, is if I take a lightsaber, Quinn, stand up for me, please. Oh, crap. And Quinn and I are lightsaber playing. I cut Quinn straight through the middle, and just like in Star Wars, you know, one half goes that way and one half goes... But the cross... No, you're still standing. You go rigor mortis immediately. Okay, the cross-section is straight across Quinn's stomach, right where I cut him, that kind of circular object, that two-dimensional shape. Okay, roll back in time, revive yourself, whatever you gotta do. That two-dimensional shape where the cut went through. So essentially, in my mind, when I'm thinking cross-section, what got burned by the lightsaber? So I take a cylinder, and I cross-section horizontally. What am I going to result with? What would I cut through? Like, what is the shape at a circle, right? A lot of people want to say I end up with two cylinders. You're right, but that's not what we care about. What we care about is the cross section through the middle. So if I cut through the middle, that's a circle, right? If I cut through it vertically, that would actually be a rectangle. Okay, so this is why we're talking before we're going to write things down. Think about this for a second. I forget if I have 3D shapes on here or not. This is going to look weird. I like things looking weird. Oh, I didn't want to do that. I want pen now. So think about it. If I cut horizontally through the cylinder, I get the circle, right? But if I cut vertically, straight across the top, actually this will be easier if I put that at an angle. Just give me a second. If I go straight across the top, straight down, straight across the bottom, and straight down the back, I can make a rectangle.
Thank you, I need that for my homework, actually.
Hence, now it all makes sense. So, yeah, you can totally sit down. Sorry, you could have said, I don't need to kill you multiple times. We can actually lightsaber fight at some point if you want. You would probably win for what it's worth.
I'm good at swordplay.
I was about to say, my lightsaber skills are lacking. So, whatever you need to write down, I'm going to write down a definition, but you don't have to copy that word for word, but it's the two-dimensional shape, flat object. That's the result of slicing or cutting into a 3D shape. So I'm going to actually say it's the resulting So here's going to be your task. And I'm going to have to decide how long you'll get with each shape. I'm coming to you in just a second. You are going to send a rep up here from your group to grab a shape. Once you have that shape, you have to define what it is. Now, if you can't figure out what it is as your group and you can't come to a consensus, it is printed on it. There's one end with a hole that you can pull it off, and then you can actually pull the net out. If it gets poked in, you just kind of have to force it to come out. But right where the hole is, it tells you this is a triangular prism, because prisms have the same shape on top and bottom, and then have rectangles connecting them. But your team wants to then write down in your notes, triangular prism, put a line beneath it, and write all 2D shapes you can get when cutting this triangular prism. Now, I'll tell you, there's a lot more than what you initially think. And I'll show you an example of that real quick before you dive in. Since we've already been talking about the cylinder, I guess let me grab the cylinder and I'll just use that again.
Wait, so is that what
no.
C-section?
Cylinder is actually kind of dangerous. Let me grab the cube and show you an example of this. Well, because you don't have as many options with the cylinder as you do others. I could, by the way, if I don't go horizontally, like if I cut through just like this, do I get a circle?
No.
What do I get? Oval, right? So circles and ovals are different from each other, so I could get an oval. Here's my advice, and I have a bin of dry erase markers over in the on the supply table out there. Over there. Blue bin says dry erase on the front. If somebody from your group grabs a dry erase marker, you can dry erase on these, and it will wipe off with just like a tissue or something. Would any of you guys believe me?
I can't
Hold on.
myself, so I'm not sure if I can believe you.
Would anyone believe me that I could make a 6-sided shape cross-section from this cube?
Please explain what you meant.
So I have a cube.
Yeah.
I'm going to cut through it. And my result, the 2D shape after the cut, would be a 6-sided shape. So check it out. When I cut here, dry erase work. Or this dry erase dried up. Yeah, apparently the lid got left off of that.
I don't want to work.
So if I cut right there, and then I cut down that side. It's really hard to see because of the glare. And down this side. It's hard to draw straight. And then down this side, I'll show you guys not on the camera. Down this side and across the bottom. Sorry, it's too bright to do this on the camera. Check it. Top, lateral face, right? Those two cuts. These two coming off these side cuts, see where they connect? And then the bottom. I've now created a hexagon out of my cube.
You monster.
So obviously, I could make a square. I could make a rectangle if I cut diagonally straight through, because it'll be longer. But then I can also make a hexagon.
Yeah, but...
And I can actually make a pentagon if I get creative. So I want you to grab 3D shapes and as a group, investigate what you can make with them. If you want to draw on them, that's fine, but then wipe it off before you put it back. So I'll put some tissues up there.
I am the representative.
Sorry, what's your question?
What shall I ever make?
Yeah, but we're not worried about that. We're gonna operate under like the mathematical side of like the perfect cut. So, like if you're actually doing woodworking and things like that, yes, you would lose mass and you would lose some length. But we're just gonna operate in the quote unquote perfect world of saying that we won't.
Why? I'm gonna put that back in my
Over in the blue bin, labeled dry erase.
Does it have to be a...
When you did not use words.
Does it have to be a straight line?
Yeah, your mind. Well, if it's curved, you have to explain how that curve works in the shape. So Quinn asked, does it have to be a straight line?
No, not if it's a straight line.
It has to be a straight cut.
Okay,
Yes. So that's what I was about to define. Is if you're working with a rounded object, all of your sides may not end up straight, but your cut has to be a straight, continuous cut. One straight, continuous cut through. So I could cut this, I could cut this, but I could also cut on the diagonal, but I can't change the angle of my cut in the middle of it. So I can't start cutting like this and then turn that way. Like your saw blade doesn't work like that.
I wish it did.
Yeah.
You can't do
No, but you can go all the way across the bottom. So this would
I didn't use it once and then you stole it from me and after.
I'm not very good at making certain it's not so
With the amount of time that we have, we're probably going to go like 3 to 4 minutes per shape to see what you can get.
Sister shape, did you break it?
You can get different size triangles right now. Can you get a flat-sided object? Or what if here actually hit before the bottom? So just think about it.
That is the right way. If we cut it in half, we would have like.
See lots of circles and ovals. And maybe a triangle? I can't quite tell. And then we need a straight cut. So that spiral wouldn't count. We want one straight cut across it.
Mr. Hudson, Mr. Hudson, does it count if it's being cut right here?
You can make a diagonal cut. It just has to continue being straight.
But if I say cut it from this line right here,
Yeah, as long as your cut is straight. So, check it out. We're going to trade shapes in just a moment. I think some of us are misunderstanding by a tiny bit, so I want to re-explain and clarify things. When I look at my cube, I cannot like draw on it. I can't just like make whatever I want. That is not a cut. A cut would have to be straight and continuous. So what I can do though, I just want to flip off this light real quick so you guys can see it a little bit easier. That light is awesome. All right, I need your attention up here for a minute. Can I make a triangle out of this cube?
9. Oh, maybe. Actually, yeah, you can. I can see
If I cut straight, and I'm talking about like I'm cutting in at an angle, but my cut will be a straight line. I could cut straight across here, right through the top, straight down this line, and straight down here. I essentially cut off a corner, but you see the triangle that I formed? So that straight cut would literally chop the corner off this cube, but I can make a triangle with straight lines that connect at the corners. I can make a square if I go straight through it, straight across it. I can make a rectangle if I go straight across and then diagonal down the sides. We've got a lot of options. Question is, can I make a pentagon? So we've made 3 sides, we've made 4 sides, we've made 6 sides. But how? So I'm going to leave that question hanging in the air. Yo, I got a lot of people not paying attention to me. I'm going to reiterate this because we're back from winter break. If you don't want to be in my class, leave. Otherwise, you're here to learn. Okay? I got people that like aren't tuning in and they're like just playing with things and they're not trying to learn anything from it. I got people sitting there not writing anything down, just trying to wait for somebody to do it for you. That's not going to fly, especially as we dig deeper into the 8th grade textbook. So, my challenge for you as the shapes come around and you trade things, can I make a pentagon with this and how? You can't just be like, yeah, sure. You got to be able to tell me how you would cut it then. So, trade shapes. Get a different one.
I've already have a different shape, so do I have to trade?
No, you do not have to trade again, obviously. So I also added triangle to this. So this would be a straight line. Right? This would be like a straight cut, but it would be rounded. So the shape you would actually end up with from that would look something like that, right? This part would be a parabola, but yeah, I don't know exactly what this shape would be called. I don't think it would be like it has a polygon name. But if you took a saw blade and you cut through here, that would be your resulting shape, right? Kind of an arc around. You can actually make a triangle with this too. No, that's not a straight cut. You have to straight line. You have to go from edge to edge. Yeah, and then straight across the bottom. That'll make you a triangle. What's up? It's the shape at the cut. So you have one side, two side, three side. You make a triangle. Yeah. Now, if you want to make a pentagon, you totally can. Yeah. So to make a pentagon with this is a little weird. I wish I had a different color dry erase because this is green. Because it's a hexagon, we need to make two of the sides, only one side. So if you make these sides go together, and then you can go, so that's 1, right? 2, 3, 4, 5, back to there. So that 1 side, 2 side, 3 side, 4 side, 5 sides. So I turn my. But it's all so we would have to be cutting at an angle through here. Okay, I'm just saying we would have to cut to an angle. But the biggest thing is we end at 2 points together because if we don't, then I'm gonna have extra sides. So actually, I could add 2 more sides if instead of hitting the vertex there, it hit like that. Imagine that we add a side there. Add a side here, and then we still have this side. Then I have septagon, like a 7 side. Glowing. Sorry, that about fell. I didn't mean to just like shove it at you. Because you're at the vertex, right? That's the trick. Whether you hit the vertex or not. Let me count sides. So 1, 2, 3, 4. 5, if you went straight from that point to the vertex, and that would be your 5. That would be a pentagon. If you want to make a hexagon, you're going to have to somehow add another side in. So I would make your angle weaker, like make it closer to flat, and then grab extra sides somewhere. You don't try. All right, trade them up. Trade them. You're supposed to be jotting down what you find. So, like, I had a cube. What shapes was I able to make? And actually, I can add a pentagon on there. I can add a triangle on there. You sure? I'm just asking, are you sure?
Yeah. Mr. Hudson, what was that shape called?
A septagon, 7-sided. Oh, the 3D shape? It was then it was a hexagonal pyramid. Guys, remember the shape's name is on it. So George asked the astute question of like, so wait, we're supposed to be taking notes? Kind of. All I really want you writing down, and I'm not really that worried about it, I just care that you're engaging with your brain. Well, give me just a second to talk. What I had asked you to write down is what 2D shapes are you making from your 3D shape. Now, I found more. I also found pentagon. I also found triangle. I just found those 3 first. I'm not expecting for you to have every single 2D shape that could happen. I just want to see what you guys figure out. Now, Simon's also figured something out. If I take the inside of the shape out, it's kind of easier to see because you can see through it. So one of the things I just did that I think maybe blew, maybe partially blew their mind, is we took the hexagonal pyramid, right, 6-sided pyramid, and we made a septagon with it. Oh. Because the pyramid has 6 faces around and an extra one on bottom. So Quinn proposed that with his square pyramid, the biggest I'm just pushing. Like, can we definitively say, like, that is a rule? So if people are gonna, we will come back together in just a few minutes. Hmm? So we go diagonally. That's how we make a hexagon. Septagon. We have to go all the way down to the bottom with these lines.
Make a triangle.
So we get 1, 2, 3. But then my 4, like 4, 5, 6. So as many pieces as you have, you can make that shape. Now, it won't be regular, right? All the same size. It won't be a regular shape. But we can make
Mr. Hudson, I got two things to point out about this. First of all, put it back in. Second of all,
you flipped this the wrong way. Oh yeah, I know that's right. No, I should have it. Oh, this is inside out. So you flipped it all wrong.
But the thing that makes me wonder this is, unless we're somehow able to bend during it, because you have to have a straight line.
Yeah.
You can't just make another straight line and then somehow face it back.
So I continue to debate bringing in actual saw and cutting up actual shapes to really like make this make more sense. You're right, but it's all about visualizing the different angles of how we get the shape. Doesn't even matter at like so even if I make this line straight, that doesn't mean that everything else has to be straight. Right? I can make this going down, but then this will have to go down to kind of match it. So I can't make this go up when this one went down. Unless I put it at such a weird like angle that this wouldn't be straight then. That would have its own angle. Right? So we could go, if I wanted to make this angular, then if this goes down, this would actually be going up in a way, and then there's gonna have to be another weird angular connection. Like we can make kind of like an awkward pipe. But yeah, we just have to be able to connect using straight lines. So as long as every line is straight and then we can connect, we can make that cut. It might be really hard to make it, but we could make it.
Yeah, but here's the thing though. Unless you have this,
Yeah.
you can kind of
Yeah.
then you take this.
Oh, I know.
On the edge.
Look, I made a rectangle.
And it wouldn't be able to cut down two edges at the same time. Well, if you do, then you are restricted to that exact line. So you try to cut down this edge and this edge, you are cutting this face off.
Mr. Hudson.
You cut down this edge and this edge, you are cutting
That one
straight
is
through.
not a rectangle.
You can make a rectangle. That is not a cut.
That's not anything.
Oh, you can't. She's right.
My other idea was bad. I made a real one and he was like, no, that was not the way. That's what I did and he was like, that's not the way.
Okay, you're right, but if I clean that up a little bit, it's a quadrilateral right now. We could make it a rectangle, we just have to get particular. That's probably not true. Parallelogram? No, if that's a triangular pyramid. You got to be careful with the triangles. Trade up one more time. Trade up. Same size. Remember, we don't say sides anymore. We say faces and we say edges.
Yeah, we're grown up kids.
Growing up kids.
We're all. I am selling a square pyramid.
We already had that. We'll get that blue thing. What is that? And you're at the bottom.
pentagon and it has the bottom face up and only make a hexagon.
Wait, it says what it is? Where?
It says at the bottom.
I told you where it says what it is.
Oh, I figured it out without that.
Is there any way? Here's a question to help you think about this. Is there any way this cut at the bottom will end up like that? Something like that. I don't think, but that's what I'm trying to hypothesize. That'd be the only way we can break the rule that you're trying to break. I don't think so. Because they have to come at straight.
I remember doing this over there, so I have
Why? Has to connect straight. Yeah, straight line between these 2 points. Making sure I have three. I'm just posing
There,
questions.
look, I made a.
That's not my job in my act like I don't know anything. You guys have to figure that out. Not I know nothing. I like acting as if I know nothing.
So that supports my theory that you can only make kind of shape.
What?
Some
Let's
size.
ignore it, R. No, it goes all the way on your face.
Alright, ladies and gents, let's bring it back together. So if you could please put the inside back into your shape and bring those shapes back up to the box. You could bring the shapes back up to the box, please.
I'm worried about going.
Bring the shapes back to the box, please.
You know what?
What?
Once we get into high school, there will be no more basketball.
Unless you go to high school that does mastery. More and more mastery is catching on around the nation and the world. Alright, I need all 3D shapes back. Connor, you have 2 of them. You're like hoarding 3D shapes back there. I need them back up here in the box. I know, but I need them back. It's like you're ignoring me.
Where does these things go?
In the bin that says dry erase, which I also explicitly announced. Yeah, I said right across the room, blue bin says dry erase. Just like when I announced that on the bottom of the shape, right by the circle, was the name of the Apparently your ears aren't turned on today. Connor, we're done. No more drawing on the shapes, man. Okay, I got you. All right. I think we should write down a hypothesis rule. Now I'm going to put rule question mark because any rule that we're trying to make starts as a conjecture. However, a conjecture, like a hypothesis, but a conjecture says, I believe this to be true, not I think this will happen, but I believe this to be true, and I need to test it to turn it into like an actual theory, which, funny enough, theory is something that's been proven. If there's like the theory of relativity, it's like it has not been disproven. I guess I'll say it that way. So like the theory of relativity, if somebody disproves it, it no longer is the theory of relativity. It then breaks. But the rule that we want to talk about here is what I'm going to nickname the Quinn rule.
Yeah.
Because he was the first person in this room to hypothesize this or conjecturize this. What he's saying is when given what he's been saying is given a 3D shape, or actually we should say object, because a lot of times shapes we use for 2D. Given a 3D object with, I don't know why I was going to say Mikey, you writing with me?
No.
With Z faces or whatever variable you want to use. F faces, I don't care.
Q faces. I want to do Q faces.
We can, at biggest, make a z-gon. So your cube, it doesn't matter, any variable. Your cube technically has 6 faces. So what we're hypothesizing here, conjecturizing, whatever, is because I have 6 faces, I can make a hexagon, but I cannot make a septagon. So unless any of us disprove this rule, that's a pretty good rule that we can operate on. Now I would ask the flip side of that question though. What would be the minimum we could ever make?
Wait, I think I know. Mr. Hudson.
Now we're gonna restrict this to polygon because we already talked about the cylinder, right? With that awkward shape, that would not be a polygon, right? Polygons have to have straight sides. Given any different 3-dimensional shape, not combine this, but think about all these separately. What's the smallest? Like, do they all share a common rule? George, you already made a rule. I want to see if George.
Couldn't the minimum on every shape be 1?
What do you mean 1? Is a one-sided shape a thing?
No, a three-sided shape.
Why'd you say 1?
Yeah, but you made one like cut.
That would not be a polygon. Gravity works, by the way. That would not be a polygon if it's a 2-sided object. It could be an object, but it won't necessarily be a polygon. So George says 3, Olivia says 3.
Divine point says 3.
There's no such thing as a two-dimensional shape, yeah. Well, if you use 2 semicircles and you made it a circle, then yeah. A semicircle
We love a sponge baby.
On any shape we deal with, I'll grab the biggest shape I have in here. A hexagonal prism, which has 8 faces, right? So we're saying we can make an octagon with this thing. I can go through these two. Connor, you don't need to fix that, man. I'm debating pulling those shelves anyways, the bottom ones. So the other purpose why I cleared off that bookshelf back there, anyone who sits at the back, you can put your books on that top shelf, but I might take off those 2 bottom shelves over there. They just tend to fall off. That's all they do. They just fall off all day. I can always cut through a vertex diagonally down towards the base, and then a straight line across the base. I can always make just a triangle if I cut through the vertex and then straight across. That would become a vertex right here, down the sides diagonally across the bottom. Make sense? So the maximums will change, obviously, but all of them share a minimum of triangle except anything rounded, right? Cylinder, what's this? Yeah, cone. Cylinders and cones, they operate differently. Right now, I can still make a triangle with this. Straight through the vertex, right? Straight down the sides, straight across the bottom. I can still make a triangle. Can I make a triangle with this?
Oh, nice. Well, no, I don't think you can.
I'm going to leave that question out there. Can I cut a straight edge triangle? I don't want an answer right now. We only have like 5 minutes left. Can I cut a straight edge triangle out of a cylinder? We're moving on, but that's a question I'm going to leave hanging for us to think about. All right. Volume related to this. I don't want to restart my computer right now. I still have class to teach. Remind me later. So I look at this, not cube, prism in part D, because I'm going to paraphrase this question because we don't have a lot of time. What are the dimensions of that?
Dimensions of what?
Yeah, 3 by 2 by 2, right? This prism, I always forget that. 3 wide, 2 tall, 2 deep. So in total, we know that, well, there's 6 cubes on the bottom and 6 cubes on the top, and the volume is 12. Now, the idea of cross-sectioning actually derives other formulas in math. Like derive means like to get or whatever else. Because if I find the volume of this, just 6 by 8 by 9, right? You know, length times width times height, that's the first volume formula you start to learn. But what if I cut it straight there, straight along that edge, straight across the back edge, straight across there. I cut it from the top edge straight down to the bottom edge. What did I cut that shape into? Well, a rectangle. Right, now this is hard to see because there's so those exist, but those aren't cuts. My cut is this. So I've actually cut a rectangle. It's kind of hard to show here. I cut from this edge to this edge. Right, but I cut this shape in half. So what I actually end up with is a triangular prism, because then I can turn it this way flat and I have a triangle on bottom and a triangle on top. So then we derive the triangular prism formula, which being half the length times width times height, right? If we still have the length, the width, and the height dimensions. So when we think about volume of weird objects that we haven't really had before, we have to keep in mind the idea of cross-sectioning. What shape does it create on the new face, right? Like this would now be a new face. That rectangle did not exist before. So this work that we're doing with cross-sectioning is to be able to visualize, if cut in a certain way, what's the new resulting face. Each of those halves, if we think in 3 dimensions, will each have a new rectangular face that didn't exist before. Questions on that idea?
I'm just making some references.
So then, we will probably very soon, if you haven't been asked to already do this, because I'm a little confused with where we are in homework and everything else, who knows what it means to be asked to make an orthographic drawing? Dave, you got an idea?
It means like if it's a 3D object, you make like everything flat, I guess. So like, I don't know.
You're real close. You're right. I mean, you're right, but I don't think you know all of it. An orthogonal or orthographic object is used to take a 3D object and show the 2-dimensional views of it. Now, isometric, hold up, guys, I have like 2 minutes. Isometric is where you still keep kind of a diagonal view, but you make it flat, and that uses weird dot paper that kind of lines up, like it makes it look 3-dimensional, but you're drawing flat. Orthographic is literally, if I look at it from the side, I could look through this opening, right, straight through it. If I look at it from the top, though, that cylinder looks like a rectangle from the very top. So when you, on your homework, are asked to make orthographic drawings, like if we took, and I forget if they name it exactly that, if we took this, and we wanted to make it orthographic, and we call this the top, the side, and the front view, like looking that way, looking this way, looking down. Well, my top view, I totally screwed that up. 2 squares, 2 squares. I don't know, this is a horrible drawing.
Horrible.
This would work better if I could draw. All right, I'm going to stop trying to make it one connected object.
Don't work, I can't draw either.
So that'd be the top view, right? This, 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 and this. But the side view, of those 2 squares, but you would also see that edge, that face over there, it would actually have 3, because it's 3 cubes deep, right? So my side view would show all 3 of those, and my front view would only have the 2, because I'd only see this face And this face, there's no other faces from that angle. Make sense? That's all the time we got. So have a wonderful afternoon, you guys.
What are we going to next?
I think social studies.
Wait, so half the grade is self.
I have 4 different. So I finished sorting this out.